think the clicker has disappeared since I left. Oh, it's because you have it. Great. Hi, everyone. I'm Kara Erickson. As Naomi mentioned, I'm a developer on the Angular core team, and I'm here to talk to you today about Angular Forms. So here's a quick overview of what we're going to be discussing. We'll start with what's new in Angular Forms for version 5. So that should be exciting. And then we're going to go into what we're calling advanced topics. So what do I mean by that? Basically, in previous talks, I've explored more introductory concepts like the difference between reactive and template-driven forms or the basics of validation. But today, I wanted to dive a little bit deeper. Once you start building forms that are a little more complex than first name, last name, like you see in demos, you start to have another set of questions, right? You want to start to make your forms more reusable. You want to split up your forms, make them dynamic. These are some of the questions that I'm going to try to address today. So disclaimer, this talk assumes that you have some Angular knowledge, like you have some familiarity with the dependency injection system, you know what a view child is, etc. It also assumes that you have some comfort building forms already, because we're not going to do much of a review. If that's not you, that's totally fine. There's lots of content online. You can always circle back to this talk. OK, so before we jump in, we will do a very, very quick review on the differences between template-driven and reactive forms, just as a refresher. So we have the same simple form here. On the left, it's template-driven, and on the right, it's reactive. So your top-level form directive for template-driven forms is something called ngForm, and that's something that is implicitly created for you every time you add a form tag if you import this module. And then it has its child directives, which are ngModels, and these will register themselves with the parent form so that it knows about its value. So the ngForm's corresponding directive on the reactive side is the form group directive, and this directive has its children form control names, and those similarly will register themselves with their parent form group directive. With reactive forms, though, you also have to instantiate your own form tree. So here on this side, you'd have a form group that you've instantiated and that you pass into your form group directive. And then on the template-driven side, template-driven and reactive forms share a common foundation, which is the form controls and the form groups. So on the template-driven side, it's the directives like ngModel and ngForm that will instantiate these same underlying models. OK, so that's it. That's your quick refresher. So now let's jump into something a little bit more exciting, which is what's new in Angular 5. So the main thing that's new is something called the Update On option. And that's basically designed to give you more fine-grained control over when your value and validation pipeline will run. So by default, every time the value changes, your values will update and your validation statuses will update all the way up the form tree. And that's normally totally fine, but in the case that maybe you have server-side validation or you have some sort of heavy processing that's triggered on value changes, that might be too often for you. So in that case, we have some new options that you can take advantage of. So I'm going to do a quick demo so you can kind of see what this looks like. So can you see that? Yeah. OK, so we're going to start with just a basic form control. Zoom. Is it too small? Of course, my Zoom is not working. All right. Let's see if we can make this bigger. Yeah, this is a new computer, so I don't have my font size set up. Sure. Is that good? OK. Live config changing. OK, so let's continue with what we were doing, which is we're just creating a basic form control so I can show you what these new options look like. So we're going to add a form control. We're going to start with a few validators. So we're going to start with validators.required. And then in here, let's maybe add a placeholder so you can see what this is. And then maybe we can display the form's value. And then let's look at the form status. Okay, so let's start with that. Oh, we need to actually look at this right here. Is that big enough? Yeah, okay, so you see we have a regular form control here. This is nothing new, right? So it starts out with an empty value and a status that's invalid because obviously it's required and there's nothing in it. So every time you type a character, you can see that the value is updating and also the validation status is updating. So this is our default behavior. But let's say your error messages maybe only show on blur. So maybe it doesn't make sense for you to be running this stuff every key press if it's not meaningful, right? Because you're not actually showing the intermediate steps. So for this, you can add update on, blur, that's it. And now, when I type in it, nothing happens, the values aren't updated, the status isn't updated. But as soon as you blur the input, everything suddenly updates. So it kind of gives you more control over when that happens. So you're not always going to have forms that have just one text field, right? Most of your forms are going to have a lot of controls. So in that case, it doesn't really make sense to have to apply each update on option individually. So in that case, if we can make this quickly into a form group. All right, so let's convert this into the ubiquitous first name, last name form. So we can make this first. Oops. And this can be last. And up here, let's just make this a form group instead of a form control. Okay, and we're going to take the validators from here. So, yeah. Okay, so let's get rid of this. And now if you want to make this form by default update on blur, you can add the update on option as the second argument. So just do update on, blur at the form group level. So once again, now we have two inputs. If you type Nancy, nothing happens until you blur. Similarly, if you type Drew, nothing happens until you blur. So it's the same thing, just on the form level. You can also update on submit. So if you are only showing your validation errors on submit, then maybe that's as often as you'd like to run this pipeline. So you can write update on submit, and then we need a submit button so that this is meaningful. All right, so we'll add some card actions here. I want to make it look nice-ish. Okay, so we're going to add a map button. We'll call it submit. Okay. All right, so once again, when you type, nothing happens. Also, when you blur, nothing happens because we're not updating until submit. And as soon as you hit submit, you can see everything automatically updates. So that's pretty cool. And that's it for the demo. So it's a really easy demo. Okay, so going back to our slides. Eventually, okay. Just a quick review of what we just saw. So for individual form controls and reactive forms, you're going to use the update on blur option as the second argument. And then for form groups, you can also use update on as the second argument, same syntax. What I haven't shown you yet is the tablet-driven version, which also is very similar. So for an individual ng model, you just add ng model options, so update on blur. And then on the form level, you have something called ng form options. And again, it's the same object. Okay, so that's what's new for Angular 5. So now we're going to move into advanced topics. So the first thing that I want to talk about is something called custom form control. And this is something that you may have heard of, but to explain what that is, a custom form control is essentially just a directive that knows how to integrate with the Angular Forms API. So if you're familiar with Angular Material, you've probably seen many of these custom form controls before. So here you can see the mat slider, the mat slide toggle, etc. Some of these are elements that don't exist in HTML, like the slider or the slide toggle. Others are form control elements that do exist in HTML, like selects or checkboxes, but they've been designed to material design spec, and we've added some functionality and features to make it more robust. So those are some examples you may have seen for custom form controls. There's some other use cases Like, for instance, you might want to wrap the control with related elements to make a custom form control. Like, let's say you have a text field, maybe you want to wrap it with its label or with its error messages that always should come with it. And another use case, which I don't see as often, is parser and formatter directives, which can also be implemented as custom form controls. So a custom form control can be used inside a form just like any native form control element. So you can see here on the top we have our text fields, and we have a select, because those are native. And then we have my control, and it's used exactly the same way, right? You add the name, you add the ng model. It's as if this is something that came shipped with HTML. And the nice thing about form controls like this is that they are form module agnostic. So you can slap it into a template-driven form, you can put it into a reactive form, and no matter which module you're using, you don't have to change anything about your implementation. So that's super useful. Okay, so to kind of explain how you might build one of these, we're going to build one together on stage through slides, so not a live demo. So we're going to build something called required text. So imagine for a second that you work at some company and you have a lot of forms, and your forms have a lot of text fields, and all of your text fields are exactly the same. You need them to all be filled out. Your app is very strict. So they all have required validation, and they all need an error message, the same error message. It might get laborious to keep packaging the same logic over and over and over. So instead, you decide, I'm going to build a custom form control, and that way I only have to write required text, and everything will come with it. So it might look like this. You have a text field. You can type in it, because it's a text field. And then it has some sort of built-in validation and error messaging. Perhaps you use it like this. It's the required text selector. OK, so we're going to implement 3 things for this custom form control. One, we're going to support everything a regular text field does. Otherwise, it wouldn't be very useful. 2, we're going to add built-in validation for required. And 3, we're going to have an error message that shows when the control is invalid for any reason. So first, we're going to start with supporting everything a regular text field does. So how do we approach this? Well, to build a custom form control, you need to implement something called control value accessor. Control value accessor is an interface that acts as a bridge between a form control element in the DOM and our virtual representation of that form control element, the form control model. These 2 things need to talk to each other in order to get the values synced up on both sides. So when you type into a text field, the value changes. It also needs to change on the model side. And if you set a value programmatically in the model, you need that to be reflected visually in the view, right? So every one of our native form control elements, like selects or text fields or radio buttons, they have control value accessor directives in Angular forms that are built in. So you don't actually see these, but that's how native form control elements integrate with the Forms API. So if you want to build a new form control, you just need to implement the same interface to tell the Forms API how to interact with your control. OK, so it's pretty simple. There's 3 mandatory methods that you have to implement and 1 optional method. So to explain what these are, so there's write value, which is exactly what it sounds like. You write the value to display in the view. There's register on change, which is a way that you can save a callback so that you can call it when value changes from the DOM side, so within your component. There's register on touched, which is a way that you can save a callback so the Forms API can properly toggle the touched property. So that's usually on blur. And then the optional one is set disabled state in case you want your form control to be able to be disabled and enabled programmatically. OK, so let's pretend this is our component template, right? The component template is on the top, and we're going to write our component class code on the bottom here. So far, we just have a text field, pretty straightforward. And we're going to implement each one of these methods in the interface. So we start with write value. So how would we write a value to a text field? Might want to get a hold of it using a view child. And then we can go ahead and set its value property. So that's pretty straightforward. OK, so register on change. So the Forms API is passing us a function that it wants us to call, so a callback function, when the value changes from the DOM. So first we have to save the function so we can call it. And then it's our responsibility to know when to call it. So in this case, on the input event. So when the user types, the model will also be updated. Register untouched. Similarly, we're saving a callback that it's our responsibility to call. So we save it as untouched, and then on the blur event, we'll call this method, and the Forms API will set touched to true. And lastly, set disabled state, where we disable or enable the fields. Text fields have native behavior for this, so we can just bind to the disabled property on the text field. Lastly, once you've implemented this interface, you also need to provide this component as a value accessor. And the reason that you need to do this is so that form control directives like ngModel and form control name can actually see your value accessor. Because ngModel will inject the value accessor token, and if you haven't provided it, it's not going to see everything that you just did. OK, so now we support everything a regular text field does. Now we're going to implement some required validation. So if we go back to our top-level form here, where we're using our required text fields, one thing you could obviously do is just add a required attribute to this, and that would totally work. That would add required validation. However, that doesn't make your required text field that useful, right? If you have to write required text and then also add the required validation. So instead, we want to build this into the component so it just comes with the component if you use it. So we're going to learn how to do that. So you might be tempted to do something like this, which is just add the required attribute on your internal text field, which is understandable. But this actually won't work the way you want it to. And here's why. So here's my very sophisticated diagram to explain this. So I guess we can all use our imaginations. This is a required text component. It's the blue box. And then underneath it in its view, we have a text field, right? So we have a really simple component that's easy to reason about. But let's say our custom form control was something completely different. Let's say it was maybe a toggle button, or I don't know, it could be anything. And underneath it, we don't have an internal text field. Maybe we have divs and spans. Maybe you click on something. We don't know what's underneath your component view, right? It could be anything. And so in the case of this toggle button, you're probably not going to have any form validation attributes because they don't work natively with things like this. And so the Forms API, all it really knows about is the interface that you implemented, right? That's your public contract with it. And this allows it not to make any assumptions about how you've privately implemented your custom form control. And so we have the same API for toggle buttons and for text fields like this. And so instead of something like required, we just require that you implement the validator interface. This is a really simple interface. It's just one method called validate. And it takes the control that's being placed on top of your custom form control, so like the ngModel or the form control name or whatever it is. And you want to return either a set of validation errors if it's invalid or null if it's valid. So in our case, it's really simple. We can use the built-in validator set required function, pass through the control, and that will take care of our validation. And now similarly, just like with value accessors, we need to make this validator visible to the Forms API. So we can provide or use a multi-provider to add it as an ng validator. And then ngModel and form control name and whatever, they can inject the validator and add it to their validation. OK, so as a review, there's only two things you have to do: add a validate method and provide it. OK. Last but not least, we want to show an error message when the control is invalid for any reason. OK, so how do we know when this ngModel is invalid? The user could have added any arbitrary validation on top of this control that we don't know about, right? So in that case, it's really best to get a hold of the model underneath, right? The thing that we check to see whether it's valid or invalid. So in that case, it's the form control. So for ngModel, you can export the directive, the ngModel directive, into a template variable, like dir. And then the form control instance is always available as the control property. So you always have access to this underlying form control. Similarly, with reactive forms, if you have a setup like this, you can always use the top level form and the get method to reach down the tree and get any form control instance that you need. So an obvious answer might be to create an input for your form control and pass through the form control instance directly. And that works, that's totally fine, but this again kind of removes the usefulness of this component that we're building. We want to make it really easy to use, and if you have to pass through the control every time, it starts to be a little annoying. So instead, what we want is a way to access the form control internally without requiring the user to pass it in. Okay, I had one more thing to say. So, so in this case, you can use dependency injection. Okay, well, you might be tempted to do this. So if you know that you're using reactive forms, you might inject the form control name directive. Don't do this. Similarly, if you're using template-driven forms, you might be tempted to inject the ng model. Also don't do that. And the reason why not is because as soon as you inject one directive or another, you're tying yourself to that forms module. That makes your component inherently much less reusable and much less portable. In addition, there's a lot of, or not a lot, but there are a few different directives. So especially with reactive forms, you'd have to support both form control name and form control directive. And if the forms API were to expand at any point, and if we were to add new directives, at some point, your component wouldn't be as useful. So instead, you can inject something called ng-control. What is ng-control? ng-control is the superclass for all of these bottom-level individual form control directives. So that's ng-model, form control directive, which is the form control that's bound, and form control name, which is the form control that you'd use with form groups. So what's interesting about ng-control is that each of these form control directives will provide itself as an ng-control. And this is a pretty neat trick, because it means that you can inject ng-control and you'll just get the closest form control directive. And you don't actually have to know what that form control directive is in your code, which means you can support everything, which is pretty nice. So it would look something like this. So you can inject ng-control, and you want to make sure to decorate it with self, or you might run into some interesting situations where if someone wraps your form control with their own form control, you might actually reach up and get a form control instance that's not actually the correct one. So you want to make sure you limit this to just the element you're currently on. Okay, so one thing that you might have noticed is that ng-control, as I mentioned earlier, is injecting value accessors, and it's also injecting validators. So how is it possible for us to inject ng-control when ng-control is also injecting us, right? That doesn't make any sense. So yeah, you can't do that. It creates a circular dependency. So for now, we're just going to remove these providers that we added, since we've kind of moved past that. And we can actually set this up a different way. So we've inverted it, so now we're injecting ng-control. So it's our job to make sure that the ng-control is still set up correctly with the right value accessor and the right validators. So we can do this by just directly setting value accessor on the control directive. So control.valueAccessor equals this. And then on the validator side, on your ng on init, you can go ahead and set the validators programmatically. And you want to make sure that you call update value and validity, because in order to make this kind of flexible, setting validators is separate from updating. So you can kind of do some cool stuff where you set things but don't necessarily update until later. Also looking at this, you might notice that we are overwriting any validators that might already exist on this control. So if the user was to add something on top, like min-length or something, it would be gone. So we can make this a little bit more sophisticated. And we can check if control.validator already exists. So if there's no validators, it'll just be null. And if it does, we can compose that validator with the validator that we want, validators that required. And if there isn't, we can just use validators that are required. And then we go ahead and set validators the normal way. OK, so now we have access to the control. Hooray! So we can go ahead and add our error message here, which is this field is invalid, which is super helpful and useful. So we can just check ng if the control is valid or is not valid. And you'll notice here that I'm not doing control.invalid. And there's a really specific reason that I'm not doing that. And that's because let's say you add an async validator on top of this. Async validators have a pending status while they're processing, right? So while they're making that async request. And so while the control is pending, it's not valid, but it's also not invalid because we don't know, right? It's in that in-between state. So in this case, you want to make sure you say not valid specifically. Okay. So error message that shows control is invalid is done. Okay, so now let's move on to our next section, which is nested forms. So what do I mean by nested form? Okay, so maybe you have a very large form, and inside each form is a bunch of kind of related steps. So the ubiquitous example for this is an address, right? These are all very related steps. I apologize for the US-centric address, but this is the only one I could find. So an address, yeah, so it has many fields, your name, your street, your city, et cetera, et cetera. And you might not want to write this same group of fields over and over and over. So, but instead of a custom form control, which is one field, as we've seen so far, we want many controls. So there's a few ways to do this. The first way is to build something called a composite control value accessor, which we'll talk about. And the second way is to build a so-called, I guess what I'm calling a subform component. And you'll see what that is in a second. So we'll start with composite control value accessors. Okay, so this is an example of how you might use an address component that's built as a composite control value accessor. So you might notice that it looks a lot like how you'd use a custom form control, right? You just have an address component, and then you just put an ng model on top of it, and that's fine. And that's because you're implementing the same interface. It's essentially the same thing, the Forms API. All it knows is that there's a control called address, and it receives an object and writes an object. So that's all it needs to know. So internally, though, rather than having one text field or divs or whatever, we have many text fields. And again, this is something that's a big benefit of using control value accessor is you can have anything internally, and it really doesn't care. It just uses the public contract, and it's fine. Okay, so if we were to start to build this address component, we have our kind of skeleton here for what the template's going to look like. So we have our two text fields. I've greatly simplified this in terms for screen real estate here. So imagine your address is just a street in the city. And we might decide internally to use a form group and some form control names to manage our state internally. So once again, we're going to implement the same interface that we've seen before. So we'll implement write value. In this case, since we're using a form group, we can just call this.form.setValue and pass the value directly in, and that should work. One quick note here, you might be tempted to use patch value here, and you absolutely can, but you want to be careful with patch value because it can introduce junk values into your component, because we're just setting it directly here. So if you decide to do that, make sure that you handle those cases. Okay, so the next one is register on change. And we have something called value changes on form groups. And a form group's value changes observable will emit anytime any of the children form controls value changes. So this is kind of perfect for what we're doing here. And in real life, you probably subscribe and save the subscription. Okay, going back to this write value method quickly, you might be thinking, hey, so we're listening to this value changes event, but we're also setting the value. How is that going to work? And it's not going to work great, because every time we set the value, when we do a model to view change, we're going to trigger a value change event, and then the view to model logic will fire. And we don't want that, right? It's wasteful, and also it'll mess up the dirtiness logic in the Forms API. So instead, what we can do when we set the value programmatically is we can set emit event to false. And this will make sure that we only emit an event in cases where it matters to us. Okay, so there's set disable state once again, and the form group also has a way to deal with this, so we can just call it disable or enable. And then lastly, we have untouched. So for this, we can implement this any way we want, I guess, but in this case, I want the form group to be touched anytime any of the child controls in the address is touched. So in this case, I'll just listen to the blur event and call untouched in those cases. Okay, so that's it. We've built our address component, so to speak, and we can use it now in both template-driven forms and reactive forms. Just like a regular atomic control value accessor, we can kind of put it anywhere and it should just work. It's very reusable. So that's one of the benefits of implementing it this way, is that it's reusable and portable. The con is you do have some boilerplate, right? You have to implement this interface. And for some people, that's not great for their use case. Maybe you don't want to optimize for reusability. Maybe you have a really simple project and you're using one forms module and one forms module only, and you just want to split up that really long form and you just don't care. And that's fine. In that case, you can maybe trade ergonomics for reusability. The trade-off, though, is that you'd have to build this differently for template-driven forms versus reactive forms. And I will tell you why. So let's imagine this is your top-level form, once again, and we just have these regular component tags. We have some general subform and some address subform. And then let's say underneath the hood in our address component, once again, that we're starting from scratch, in our component template, we just put an ng model group with some ng models inside it. And so you might expect the ng model group to work with the ng form on the top level up here. However, that won't work. So you may or may not have seen this error before, but you're going to get a no provider for control container error. And so this is actually a really quick fix. It's a one-liner, but I kind of want to explain what's happening here. So what is a control container? Should probably improve that error. So a control container is the superclass for a bunch of the form control directives. So it's a superclass for our top levels, like ng form and form group directive, and it's also the superclass for our grouping directives, like ng model group, form group name, and form array name. So the reason the ng model group is looking for a control container is it's looking for any of these directives. So ng model group, its job as a directive is to kind of look up the tree and find its parent form. Its parent could be another group, because these can be nested arbitrarily as deeply as you like, or it could be the parent form. But ultimately, it has to resolve to a parent form, because the parent form is, especially in ng form's case, the thing that actually does a lot of the heavy lifting. So in this case, our top level is ng model group. It can't find the ng form that it needs, so it's going to throw an error. So you might say, there is an ng form, look at it, it's right there. But that's not quite going to work. So if we imagine that ng model group is injecting this control container, it's going to start by looking at its parent here, looking at its parent, which is the required text component. It's not going to find it. And then normally you'd think, oh, well, it's just going to look up at the form tag that's directly above that. But it's not quite that simple, because ng model group, if this is kind of a simplified example of what the constructor looks like in the ng model group source code, it has a host decorator. What does that mean? So a host decorator is going to make sure that the ng model group doesn't look above its view for its control container dependency. Why would we do this? One reason is that eager registration across component boundaries like this can be pretty risky. What that means is that third-party components would have perhaps unexpected side effects on your app, because it could kind of reach all the way up and register itself with anything, which is not great. Also, control value accessor depends on this level of encapsulation where things are completely separate. For instance, if you were building something like a slide toggle and internally it was a checkbox, you wouldn't want that checkbox's ng model to register itself with your form. You want it to be a slide toggle, right? So it kind of depends on having these barriers. What you can do to kind of get around this and say, hey, no, I mean it, I actually want to register this ng model group with an ng form, is you can use view providers. So you can provide the control container that it's missing, and you can use the existing ng form that's already going to be in that dependency injection chain. So why view providers instead of providers? Most people use providers, right? If you were to provide control container in providers, you would be providing it at this level. And the host decorator creates this lovely dotted line, which means that the ng model group can't reach up and see it. So you're still going to get the same control container error. View providers are provided on a different level. So if you provide it at this level, your ng model group can happily find the ng form that it's looking for. So once again, you provide control container this way, and you're done. OK, so pros and cons. So as a pro, it's quicker to set up, despite the long explanation. And the con is that you limit yourself to one forms module. If internally you're using an ng model group, it has to be used with an ng form when it's being consumed, otherwise it will never be found, right? OK. So let's move on into the reactive form version of this. So again, we have our top-level form. Instead of our ng form and our ng models, we're using a form group directive here. And again, we have our address component. And then for all reactive forms, of course, we have to instantiate the form group in the component class. OK, so once again, we're starting from scratch. So let's assume this is our address component template. And at a top level, it has a form group name. And we want it to register with the form group directive that's on top of it. So once again, we can use view providers with the same trick. So we can provide form group directive instead of ng form. But we have one more problem. And that's because reactive forms registers, or its directives, their job is to take an existing form group, existing form controls that you've created, and match it to the DOM, right? And in this case, we don't have those form controls. They're not being defined here. So in our address component, we can inject the form group directive, and we can add the control when the address component is used. This way, obviously, the top-level form doesn't have to add the address component and also add the controls, which would be confusing. OK, so that's it for nested forms. And our last topic of the day is form projection. So what is that? OK, so we're going to explain this with two examples, or two use cases. The first is an error aggregator. So what's that? So if you do a lot of online shopping, like some of us do, you might be familiar with a shipping address form that gets very angry if you're missing fields. So if you can see at the top here, all of the errors are aggregated at the very top. So obviously, you can do your error message however you like, but this might be a common pattern that you're using throughout your app. And so you want to build some sort of form that wraps this error aggregation logic, so you don't have to do it over and over and over again. So maybe your plan is to do something like this. Internally, you have a form tag. Again, this is your component template in your component class. Internally, you have a form group. And you want to project the form contents, arbitrary form contents, from any form into this form tag inside the component. So perhaps you would use it like this. You'd have a wrapped form component. And as its content children, you would have the nested form group name. So if we were to continue with this, you'd have some sort of error logic here. I'm not going to go into it because that's not really the point of this. But the problem is this isn't actually going to work. Why is it not going to work? So if we go back to our sophisticated diagram, we have our wrapped form component here. And underneath it, we have our wrapped form view, which is our form group. But it's actually a little bit more complicated than that. We also have content children. So we have both our view children, like form group, and our content children, like the form group name we're trying to project into it. And if the form group name is looking for its control container, which it always will be, it can only look up, right? So it can look for it in the wrapped form. It can't look for it inside the wrapped form's view. So it's not going to find it. So how do we solve this problem? The first strategy is don't do this. Don't project forms. But don't worry, I'll give you an alternative. A better way often is to relay the control instead. Why? If you're projecting forms, similar with nested forms, you're tying yourself to one forms module. If your component internally has a form group or it has an ng form, then the only thing you can project into it is the corresponding directives, right? And so again, you're limiting your reusability, your portability, etc. Also, typically there's a better design. There's probably a way for you to break this up into pieces that are a little bit more understandable than something like this complicated provider tree. Also, doing so can be tricky to get right, and I will show you that in a second, so you will believe me. Okay, better design. What's another way you could build this error aggregator instead of putting a form tag and your error tag inside the component? Well, you could create an error aggregator component that only has the error aggregation logic, and then your user can wrap that error aggregator with any form tag or forms module that they choose. So in this case, it's really obvious what's happening, and you're just relaying the form group into the error aggregator. And another huge benefit of designing it this way, like I said, is you can use it with both tablet-driven and reactive forms, and it's just going to work because you're just passing through the form group, which is common to both modules. Okay, so in this case, we have an input that takes the form, and most of the other logic isn't changed. Okay, so let's think of another use case. What if I had a form wizard? So you may have seen this in like, Google Forms or just other forms around the internet, where you have a bunch of subforms, and you can't move on until you hit next, and you can't hit next until your form is valid, right? So it kind of takes you through the form process, but each step must be valid before you can progress. So if you were to build a stepper component where arbitrary forms could be nested inside it, your forms or your form stepper would actually need to know about the validity state of each subform, right? So it's easier to see if you look at it. So let's imagine again we have our internal form tag. And then in our application level code, we might use it like this. You have a form stepper, and then we're trying to content project all of our arbitrary steps, which could be any form at all. And then each step contains part of the form, right? So that might be your initial design. Strategy 1, don't project forms. That's one strategy. Relay the control instead. So this is actually what we do with the Angular material stepper. So there's a real use case out there. So in this case, you could do something like each step could be its own form. That's something you could do. If that's the case, then you can go ahead and pass that control directly into the step. And that way you can figure out whether the control is valid before you press the next button. And again, this works with reactive and with template-driven. Another strategy might be to, instead of have each step be its own form, you could wrap all of your steps in one form and then use the magic of form arrays to make everything work. So obviously this is a reactive-only strategy, but you could pass in the steps array here, and then each of your steps, the form group name could match the step index, and that would be the way that you could get it from the array as you kind of go through your steps. Okay, which brings us to strategy 2. If you really, really, really need to project your form, you have a really specific use case, you can do it. Huge disclaimer though, it's tricky to get right and leads to bugs, so please be careful with this pattern. Okay, so again, we're back with our initial design. How do we make this work? So again, we have a diagram. So let's assume we have our form stepper component at the top, and we have our form stepper view, which is our form tag internally, and then we have our form stepper content, which is our ng model group. So how do we provide to this ng model group and the content children the form that's in the form stepper's view children? How do we do that? Well, somehow we have to get that information to the parent, to the form stepper, because that's the only thing that the content children can really see. So we can do that with a viewChild query. We can reach into the form stepper and grab the ng form. It's underneath here. And then we can provide the control container using a factory. So we can get a hold of the form stepper, and then we can look at its form property to get to that viewChild query that we just created. Oh, that's blurry. OK. So this is from Angular.io. It's our lifecycle hooks, right? So you might be thinking, How is this going to work? Content children are always processed before view children. And you would be right. Look at this handy diagram. Content init happens before view init. So won't the control container always be undefined? And you'd be right. Initially, it will be undefined because of the order of things that happen. So to make this work, we have to wrap our step in an ng template so that we can kind of choose when this is instantiated and when this is processed. So internally, instead of using an ng content, which you might be used to, we can use an ng template outlet, and then we can use a content child query to grab that ng template that we projected. So you can see why that's a little bit complicated, right? But it is possible, and you'll see this example and all the examples for the code today that we went through online. I'll be tweeting it later, so keep an eye out. So in conclusion, I have one, okay. So to kind of review, because I know that was a long talk, we have new validation timing options, which you've probably forgotten about by now. So those are really exciting. Custom form controls are really useful and powerful, and you can use them for a lot of things, and they are not scary. Nested forms are very possible, and what strategy you use kind of depends on your use case and the trade-offs. And don't use form projection if you can help it. Thank you.